All right, so I picked this exercise as one of the CSWA discussion items. The decimal places are two decimal places. There are a couple of bilateral dimensions. Mainly the threads, the thread callouts. You should look for those, but on the CSWA, you're probably not going to encounter those. And so, kind of going through the strategies. This is one that is complicated enough that I would be looking at a layout sketch to get me the base dimensions. Time-wise, this is probably a little bit more complicated than what I would expect to see. And again, some of the dimensions are a little bit more detailed than what you're going to get. So let's pull that out of the way. We'll go into the inch part. And for an origin, we're going to start on the lower left corner on the left view. So from a front plane, and anytime you have a level of complexity and are going to take on the layout sketch as a strategy, we're not so concerned with cleaning everything up as to getting a size and a working envelope as quickly as possible. So let's see, for our height, am I going to be looking at stack ups, or let's see, so to the center of the hole, 4.5 with a 1 1/4 radius. So that puts us at 5.75. If I find out that's not the case, then I'll have to make the adjustment. 7.5 on the overall. Let's go ahead and put in the circles for reference. And we'll stay with the nominal values on these. So 1.75. And its location is 2.88 off the edge. All right, so one of the other things I want to look at going through this process, if we do end up with these rounding, with a rounding error, rounding issue, how much are we going to gain and lose as far as positional tolerance? So height-wise, need my glasses on that one. 1.62 for the location, and then to the upper circle. That one was the 1.247, 1.25 bilateral, but this is one of those cases where I'm not so concerned with maximum material condition. It's going to be easier to identify the nominal fractional number. All right, so 4.5, and then its position. Yep, I think they came 3 inches off of this back edge, or from the center of the bores. And then that'll give me my location, or a few other pieces of geometry to start to make this work. All right, so the outside body. If I'm reading that correctly, was a 3-inch bolt circle, so 3 inches to the flange. And I'll pick up my quadrants for reference. Alright, so let's see, we have a height. Maybe not, it just kind of builds that way. Alright, so we'll come up the 0.76, come back across the face. And then the overall was 5.76. Alright, so the riser, now if we go that route, if I calculated that correctly, then we had the 4.5, 5.5, 5.75. Then one line will drop from the quadrant back to the base, back to the bottom. All right, so that gives me a starting point to work from. All right, the back side, not too much there to worry about. The right side, there's still a little bit of build out there. We're just gonna have to start on the front flange. So I'm going to take a second and rename the sketch to layout. I don't want to include it in any of the geometry, so front plane, going to convert the two pieces of geometry into the sketch. And set the circles, and that was a radius, and that was the thickness of the flange, also 0.76. And then the dimension, 3 inches was already there. Oh, and that was the diameter. So I need the radius, so jump over to the liters, change it over. That'll look a little bit better. And then we'll go for line to line. And if it'll give me a direction. I think I missed that one, so we'll go tangency. Double check, have a tangency on the upper, none on the lower. Tangency. Alright, double check this one. Nope, didn't pick up a tangent there. And mirror. So this one has enough little tidbits of information in it that I will go ahead and trim out some of the complexity. Need that one. Okay. So still like the single trim as opposed to the power trim. We're going to go ahead with the feature extrude boss base 0.75. Building everything off of that front datum so it can go back. We're going to end up with tangency, so from the front face. Don't really have to worry too much. I'll get back into my sketch. From the face, new sketch, convert the existing geometry, and then we're going to do an extrude. And this is going to be the overall length. See, make sure I have my numbers. So from the front, 7.76, And then there's a looks like a 0.38 overhang. So plus 0.38. And not really any merge result to merge. Alright, and it looks like I still built that the wrong way. So edit the feature, reverse the direction. Alright, you can double check. So edit the feature, reverse the direction, might have double clicked, and go to the rollout. That was what was happening. So edit the feature again, reverse the direction. Now I have everything going the way that I want it. Alright, so haven't included any of the holes, any of the other geometry. So if I'd built that out, then I could have started from that plane, but so I made that decision. I come back, pick up the location, and don't forget that you have in your extrude a from, surface and face. So start at that face, and then the blind condition for it goes back 7 inches. And check for the direction. And missed something there, 7.76. Oh, so the flat went. Alright, went 7 inches back. So the flange number either doesn't line up or I missed a dimension. Alright, so plugged in a number and went the wrong way. Alright, so 7.76 plus 0.38, and double check that I've got the extension. Alright, so there's the overhang. Alright, so from that that base then, let's see, we have 1.5 back. Need to look for position. Now we have 4.76 to the center and 3 inches overall. So that's kind of a weird way to do that, but let's go ahead into the sketch. Front plane. Go ahead and convert my entities. Trim out the extra. Alright, so to the center of the boss is, double check that, 4.76, and then we're 3 inches either side of that dimension. So that stack up, extrude, we have a starting plane that is offset. So from 4.76, and I need to get back to my isometric view so that I can make sure it's going the correct direction. It has a 3 inch, but it's not blind. It's going to be for the midplane. So I can manipulate the dimensions to figure out its location. Alright, so there's a filler piece, and I have to decide if I want to include that filler back to the geometry, so that looks tangent. Go back into the sketch, and we'll look at this from the back. So from the quadrant, and at this point I haven't put any of the hole locations in or any of the whole geometry, so okay, get to my center point, coincident, have the tangency, and if I don't trim this piece out, then I know I'm going to get an error. Show problem, exit the sketch, and rebuild anyway. And go back into the feature. It goes over to selected contours. When I select those two regions or the two contours, then I'll get the desired result. Okay, so we have those shapes. I'm still not sure that I want my whole geometry in just yet. So that being the case, let's go ahead and open up a sketch on the side. And this is going to be a vertical, similar to what we just built. All right, so the outside geometry, 2 inches on the circle. And position-wise, we can double check. I'll put a center line in place. And for my double check, I'll go from the front back to center. I know that that's going to be a driven dimension, but I want it to be able to travel with that geometry. All right, so it's vertical component. Don't see that as being tangent. Yeah, kind of looks like there is an overhang as well. All right, so if the 0.24 goes to the bottom of that flange, then we need to go ahead and finish out the rest of the geometry. All right, so in this case, since I missed, and it does look like there's a little bit of a step there, let's go back to the front view, edit the sketch, and rather than going through the process of trimming this out, I'm going to put in the 0.24 and just see what that does to my region. All right, so there's my step. It will mess with the sketch. So I made a choice, and we need to edit the sketch and get back into the geometry. All right, and this is going to be one of those cases where the relation, the coincident relation on the bottom is the issue. But I also have to be prepared that I may have manipulated the geometry enough that I need to verify that I'm on the correct sketch plane. All right, so those were equal. All right, so we're in a diameter. This was a radial dimension, so radius of 0.38. So if I go to the 0.76, we'll change back to the radial. And if those are done correctly, then that face will be tangent. All right, so previously we trimmed this out. This time I'm going to go for the regions, and we'll see what the differences are. Alright, so tangent on that end, not tangent on the other end. Oh, wrong button. And we'll go ahead and set up for the mirror. Alright, extrude. And I don't have a number, I have to the overall. So in this case, I'm going to go up to vertex. And the vertex will be the end point of my layout sketch. And we need to select the contours, and the issue with contour is going to be that if I try to grab the outsides, that's not going to give me a desired result. I'm going to need to be in the regions, and then as I go, verify that I've collected all of the regions. Alright, so we have a point, we have up to vertex, we're merging the result. Oh, this is not a thin feature. And it stops where it's supposed to, except for, oops, one tangency. Alright, so we'll double check, and it wasn't a tangency issue. It was what I said about the contours and regions. I missed one. Alright, so jump back into the contour and region. That looks pretty good. Alright, so at some point I should save this. And this is exercise 13.2. Alright, so I've got the main body of my geometry in place. There is a cutout on the back side here. So I'm going to use just the rectangle. We can stay tangent or coincident in this case. And we haven't set a height yet. Let's see, radius, nope, nope, nope. So, that's a good one. See the 2 inches back. Let's jump over to the drawing, see if I can pick it up over here. So we have the 2 inches for depth. The flat, 1 inch right there, 1 inch off of the center line. Okay, so we'll come back to our line. Now, make sure that I have the correct selected. Okay, and then that's going to be an extruded cut of 2 inches. So that dimension doesn't fly. Alright, 4.76. That should be slightly forward of that dimension, not slightly back. Okay. So double check, 2 inches. Double check that I have the 3/8. Alright, so let's see. Now they have a dimension to center line of 1.62. Oh, that's to the whole location, so that makes sense. So I'm not seeing where I missed that cutout. So these are the kind of little things that as you're going through the process will trip you up. So let's go back through the math real quick. 7.76 overall. Take a couple quick measurements. Mm, 8.14, 7.0 on the length, 7.76. Right, and then the 0.38. Yep, one of those numbers has to give. Either the 0.38 is not to the center, okay, from that end point back, so we come back to 7.7 3/8. Still doesn't make sure I didn't reverse that. No, still come up with the same number. Alright, so that's going to be the problem without an overall dimension to work from. The stack up. So this dimension I'm off by, if that were to come up flush, I'm off by 1/8 of an inch. Alright, so real quick run through the check. 0.76. Yep, force of habit, 0.75. Well, let's correct that. Now the other thing would be that I made an assumption that the base was 0.76, but if that actually intersects, then we would have the 0.38. So, getting the feature, let's go to an offset instead of selecting the face, 0.38. Make sure everything rebuilds. Oh, and that went the wrong way. Okay, still okay with that. Okay, set the direction, look for the face. Nope, that's still not working. Back through, but that does help with the intersection. Okay, so the 4.76 from the face to the center. So here's one of those places where we'll go to the temporary axes. Alright, temporary axes, back to the face. Well, that's not going to give it. Let's go to measure. And that is correct at the 4.76. Okay, so we'll double check the midplane number. All right, so 4.76 midplane to 3 inches. Okay, so another quick check. Since that's 4.76, but then that's definitely offset, then where am I missing a dimension? Well, it's definitely not centered, and it's not not giving me another offset dimension. So have the relief cut. All right, so the 2.76 off of the face. Oh, I missed that one. There I go doing math again. All right, so another quick check. All right, so we can turn off the temporary axes. Nope, 3.26. Well, that would do it. All right, so in the mix and match, I definitely missed a dimension. So offset of 2.76, and that was from the from the back view. And then blind in condition, make sure that my directions are going okay. All right, so once one thing changes, fix that. But now I've got another issue with the boss. All right, so let's see what occurred there. So tangent-wise, bottom edge to tangent, move that up, and maybe instead of tangent, we'll go with coincident. That makes that correction. All right, so that looks okay. That looks okay. Double check the number again. All right, and don't forget to save off and on. All right, so I found my mistake, and ready to move on to the next geometry. All right, so pretty much through with the layout, so we can hide that. And what else do we have that's major? I think everything else is pretty much hole locations and fillets. So I'm going to go ahead with the hole wizard, and we'll look at this from the top. All right, so the definition is 4 times a 656. So through location, let's go with fractional drill sizes. That's going to be a little bit above 5/8, a little bit below 11/16. So show the decimal values. There we go, 656. And this is one of those cases that with 3 decimal places, where are we at? 2.5 of a thousandth, 25 millionths, however far we want to take it out. We have to decide if that's going to be a problem for us. And so in that case, it may be better to draw it in. Let's go ahead with through, although I've already kind of committed to the to this course, so we'll see what the difference is. All right, so one location, we're going to end up with 4 of those. Vertical, select, and vertical, horizontals, still missed, horizontal, and then dimension, 4 inches between. No, that's on the outside. The other one was 4.76 on the inside, so they're not going to be at the same horizontals. All right, so that horizontal and that horizontal need to come out. All right, so 4.76. And its dimension off of the leading edge is 1.5. And then from the trailing edge, nope, got those reversed. All right. All right, so 1.5. And then this one is the 4.76, so easy to transpose those numbers. So that means this side is going to go to 4 inches. And we'll just double check real quick. All right, so 1.5 off the back side. And then from the inside, see if I can pick those up. All right, so 4.76. Yeah, 4.0, 1.5. Oh, and then I was looking for 4.24 between. That's a tough one. There's not really a center line there, so we have to see what it ends up looking like. Alright, so there's the location, center line. Alright, so the leading, those all look pretty good. Alright, so what I'd be interested in is, are they centered on the base, 0.76 and 0.76. Alright, so we're kind of whittling this down. Let's go ahead and put the relief in. Okay, radius of 0.5, so 1 inch. Gonna need another center line, so 4.76. There are a lot of 4.76s in this one. In this case, instead of drawing the center line, I'm going to turn the temporary axes back on. 1.62. And then this is going to be an extrude cut. Go back to the isometric so we can check direction. Reverse the direction up to next. Okay, so it's starting to look like something. Okay, so last couple pieces of geometry then. Let's go ahead through the face. Well, I picked something. Let's see, did I actually get the face? All right. .25. All right, again, not so much worried about maximum material condition, just getting a nominal size in. This is going to be an extrude cut through all. Go back to the front face, open up the sketch. And then it's not really called out on the definition. It's kind of hard to tell what's going on with the intersection of the two holes. So 1.25 on this side going this way, if that's a flat bottom step or if it's a drill point angle, we don't really know. So we're going to stay with the flat bottom, 1.75 to 3.76 deep. Okay. There's our geometry. Still kind of hard to tell. What else do we have? Through hole. And that is a 1.25, and it's going to be through up to next. Oops, get out of the from, go through all. All right, crossing last few items off the list. Pick up the center point, dragging along the edge. And nominal, this was an 8. That's an interesting call out. Let's take a look at that one. Diameter 8.75. Spot face of, or counterbore of 1.25, 2.5 deep. So I don't see that hole coming all the way through or to the intersection. So unless the call out is for the 0.25, but that's open to too much interpretation. So I wouldn't expect to see that on our CSWA exam. There would either be a side view or detail view that would call that out. So I have a knack for finding the ones with weird errors. All right, so making a design decision, I'm going to say the 1.25 is probably a fairly small spot face based on what we can see. Well, let's see where it intersects at. Again, not knowing what goes in there. And no additional detail. and it is called out as 874 hole, so nominal or mean value. All right, let's see what we get. 0.875. And again, is this going to be a flat bottom or is it going to be a drill point? We don't really have enough information. Would expect that the detailed drawings on the exam though will give you much better sense. All right, so we're going to pull out the 1.25. Alright, so we made that 2.5 deep. Spot face is usually 30 to 32nd to 1/8 of an inch, so 30 thousandths to 0.125. Well, we're kind of at that past that point of getting usable data out of this particular drawing. So making another design decision. Then let's go to our tapped hole and we'll jump into the center. And we had tangent, but we didn't get to center line. So there's another error that I made in the process of made those couple of assumptions. Let's go back to the boss. I edit the sketch. We're going to find the one with the midpoint. All right, so there's the relation for the midpoint. Relation for another midpoint. All right, we'll make sure that we're staying coincident. But when those shifted, 4.76, yeah, it actually shifts to the backside and to the bottom. Well, that's interesting. All right, so we'll check for the top, and 2.5 doesn't quite get there. All right, so double check for the notch. All right, radius of 0.5. (1.2 to the 1.62 to the center. Well, there is a possibility that 0.875 is missing its depth call out, and the 1.25 counterbore is actually correct. All right, so 3/8, half inch. All right, we'll see what they're doing on these call outs. All right, so the first extrude, the sketch was okay. Let's go to the feature. Let's go ahead and make that one just a little bit deeper, and then the cut extrude. Let's go to a counterbore of 2.5. All right, well, that makes it to barely to center line. All right, so let's see what we can do. Here. Counterbore 406, a half inch deep, and then 3/8 beyond. Okay, so sketch. And missed. All right, Alright, so extrude cut 0.5. And again, not really sure what I'm looking at or for, so I can double check. So that gets to the point. Let's go back to the hole wizard, tapped hole, bottoming tapped. Let's just go with tapped. 3/8/16, and it's not going to be a through all, but it might be an up to next. Alright, so if we're looking at getting up, and since I didn't jump over to position, I get to go back and pick it up. Alright, so the depth, alright, so this kind of shifted into design mode as to what is going to make the fix. If we were on a drill point as opposed to a flat bottom, 3 inches to the shoulder would probably intersect it enough at the point. Depending on what the 3/8 is actually doing. If it's a port for fluid, then that's different than it being a set screw for retention. Alright, so let's try and get this wrapped up. Alright, so the our view is showing intersections on the fillets, which I normally would not put the fillets in first. So let's go ahead and finish out the still have more 3/8/16s. Okay, so those are 5/8 deep. Let's go ahead and get those into place. And we have the depth. We need to make it a blind in condition. Thread depth 0.62. And then the hole depth that should have updated, which it didn't. Alright, so go to 0.62. And if we go a 1/4 inch beyond that, that's going to put us up at, let's go ahead and call it 7/8. Positions are going to be to the centers. And I'll go ahead and select and accept. Alright, so the issue with the last 3/8/16s on the face is when they penetrate through the backside. If the fillet's there, it's going to not show geometry, I guess that's accurate. So I don't necessarily have to put in all of the fillets, but I do need those fillets in place before I make that intersecting cut. Alright, so back to the S key and 3/8/16. Oh, updated to 0.933 for me. Alright, so the call out for the front. Oh, 7/16 14. Well, that's nice. We can just go back and double check our numbers. 0.875 for the thread depth. Do want to run it through. Well, let's see what it looks like. Position wise, let's find our centers. Double check the call out. 7/16 14. That looks a little small, but yeah, it's about what it looks like on the flange. Alright, and then there's the cut back and relief into the end of the threads. So probably don't need to go that deep. We do want the threads far enough. And if we look at it from 1 inch, okay, that seems somewhat reasonable. Alright, and then I didn't see any other radius callouts, so the trick here is to get the radiuses in without generating any additional errors. So let's go ahead and pick a block of easy ones. And, well, we'll go ahead and try. Go into the fillet. And we're going to add one more. No, I'm not getting the preview, so I must have already have enough geometry for it to figure out. All right, so far so good. Got to make an assumption that it goes underneath. And again, this being a casting, it's not unlikely that it would have. Oh, there's all of the rest of the selections. So no. Yes on that one. Let's see, go to the outsides. Alright, so let's see, intersection. And I'm still going to lean towards the edges over the faces because I can see the tangency is a little bit easier. And we have the fillet expert come up. So I didn't exactly catch when I started missing. So if we go to the fillet expert, I don't think it picked up. Nope. Darn it. So I get to go back and pick again. Alright, so let's see what happens when we get face. Nope. Well, pick through that geometry. Alright, I'm getting more tangencies this time. And that one failed. Alright, so we'll take it out. As long as I'm seeing the previews, I'm going to keep going. Alright, so it looks like those two interior, well, probably more, but those interior edges are hanging up. Alright, so let's see if we can go around. One, two. Go ahead and accept. Well, it's a pretty heavy duty fillet on the front, that's for sure. Alright, that's another one of those can't tell. I'm making an assumption that it's there, but can't really tell that it is there. Alright, so one more check. Nope, I did miss the two. Alright, we go through all of that. I said the origin was going to be on the front edge, but because of the way that I made my selections and I started pulling my datum references, oh, I missed another one. There we go, one more fillet. Alright, so blends, fillets all over the place. We can do with a lot of design per manufacturer on this, and cleanup. Depends on what it needs for clearances, but alright, so I picked the front face. We had the trouble with the offsets. Going through this group, not a not a tremendous amount of features, but we got up there pretty quick. Let's see what else. I don't really see them. All right, so the issue becomes picking off of the origin. If that's my origin, if I wanted it to be on the corner to some other location, then I'm going to have to create the coordinate system. So let's go ahead and save. And under evaluate, we'll go into the mass properties. It's referenced off of the origin. And so, I didn't set a material. So material is going to have an effect. So let's go with the 1020, which will be pretty close. All right, mass properties, we went from 3 pounds to 29 pounds. So the default should be 1 gram per cc, or the mass properties of water. Okay, so volume, center of mass, and in that location. All right, so if I wanted to change this this position, now let's find something a little more convenient than the radius edge, since I'm going to have to build it out anyway. I'm going to open up a sketch, and we'll go from midpoint to midpoint, and that can be horizontal. All right, so it gives me a location to work from. All right, so if I needed to put my coordinate system in the bottom middle, then I have the point for the origin, X and Y locations. Now set it. Now other options would be to go into direct editing and move the body over to a new origin location. Downside to doing that is that that number is going to be, I would think, a little bit easier to miss. So if I can pick existing geometry, the chances that this would be in the bottom middle aren't really that good to begin with, but on the off chance that they are, that would kind of drive my sketch and some of my original assumptions. So let's go in and make sure that under the evaluate, go into mass properties, double check that I am picking the new coordinate system, and we'll watch the center of mass. The volume and the mass of 29 pounds shouldn't change. What should change is the center of mass 3.87 goes to 0.99. All right, so this group of numbers here is what's going to update as we make that adjustment. All right, so when we're through, we can go back and hide those extra items. Control 7. Hopefully I didn't miss any fillets anywhere, miss any geometry. We had some questions on the counter bores and the depth and the intersection and the drill points. That information would be called out in much greater detail on the CSWA. So kind of the risk I run when I pick a part out of the tech drawing and run with it. So again, some of the challenges, some of the easy mistakes that you're going to run into, have to follow up and be able to catch them.